Assalamualaikum and a very good day. We are Group 5 from Integrated Design Project Section 6 and we will be presenting our project. Our group members consist of Muhammad Faris bin Abdul Hakim, Nur Atira binti Muhammad Rusli, Nur Lidiana binti Khalid, Nur Izzah binti A. Manja. Our first presentation would be the structural design. My name is Nur Lidiana binti Khalid and I'll be presenting the company profile. Our company's name is Berjaya Consult Enterprise. Berjaya Consult Enterprise based in Johor Bahru, Johor. It is a private-owned company led and run by Bumiputra. The function of the establishment is to carry out business services of urban planning, project management, and construction. Here shows our company information. Our address located at Jalan Padi Perak 31, Bandar Baru Uda, Johor Bahru, Johor. Our contact information shows our telephone number, our fax number, and our email. The vision of our company is to be a leading multinational corporation delivering better value in construction field. Our mission is committed to develop a better future for next generation. Here shows our organization chart. Our director being Muhammad Faris bin Abdul Hakim, our general manager Nur Atira binti Muhammad Rusli, and under her our contract manager Nur Lidiana binti Khalid and project manager Nur Izzah binti A. Manja.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izzah binti A. Manja, CF 200167. I will present about the project background. So the project location at Bandar Indah Mahkota, Mukim Kuala Kuantan, Kuantan Pahang. So the type of building is 4-story commercial building. So what is the type of commercial buildings? So commercial building can be office building, house commercial activity, warehouses, retail center and resident, or it can be a business professional use. For the project detail, the project name is the proposal of developing commercial building at Bandar Indah Mahkota, Kuantan, Pahang, and the developer or the client is the Sentimental Associate Sdn Bhd. The architect is ATZ Architect, and for the CNS consultant, M&E consultant, QS consultant, and the town planner is from our company, which is Berjaya Consult. And the company address is at Jalan Padi Perak, Bandar Baru Uda, Johor Bahru. And the project address is as stated before, which is at the Bandar Indah Mahkota, Mukim Kuala Kuantan, Kuantan Pahang. And the project cost is estimated in about 1.3 million because we built in a two building. So the project duration is in about 16 months. Next is the project scope. So the project scope is the commercial building types of a space is designed for higher occupancy and can range in size from a single-story building to a high-rise building. In the pre-construction process, all preparation material including bill of quantity, BQ, and drawings such as architectural, structural, mechanical, and electrical drawing must be prepared from our company. And the design preparation for the drawing was follow the standard specification used, Malaysian standard, which is a Euro Code 1 and Euro Code 2. And for lastly, for the process of the project also include the development of infrastructure for the buildings such as earthwork, drainage, sewerage, road, water reticulation. So all the project must be complied to these rules and regulation from the local authorities. So that's all from me. Thank you.
Okay, next part, we'll continue the proposed size and thickness. Depth of foundation. Based on the soil investigation, the chosen foundation to be used is pad footing. It's commonly used for shallow foundation in order to carry and spread concentrated loads caused by column or pillars. The type of foundation used is necessary to ensure structural safety. When one or more soil layers are very compressible and incapable of supporting the load transferred by the superstructure, the bearing capacity is 150 kN per meter. Okay, this is the foundation will be categorized into four groups, which is from Group A to Group D. Group A is estimated pile depth is below the 4.5 meter, which Group B 4.5 meter until 9.5 meter, Group C 9.5 meter until 14.5 meter, and for Group D 14.5 meter and above. The size of the beam. The size of the beam to be proposed from the ground floor until third floor is the same, which is the span length and the dimension. Which is for the span length is equal to 14,850 and the dimension is 150 times 400 millimeter. So it's the same for the ground floor until the third floor. Next, for the thickness of the slab. The thickness of the slab proposed is for the span 5A until B, the length is 3,600 and the dimension is h equal to 150 millimeter. Next, for the size of the column. The size of the column proposed is from column C1 until column C5 is the same size and the same length, which is the length is equal to 3,000 and the dimension is 400 times 400 millimeter. So that's all for me. Thank you.
Warahmatullahi wabarakatuh. My name is Natira binti Muhammad Rusli, number matric CF 2095. Today I am going to present on result analysis. So as you can see, there are two tables, which is table of manual calculation and table of calculation from STEAM. For slab design, we provide transverse reinforcement with size ranging between H10 to 50 to H10 400. Compared to STEAM software, they provide reinforcement with size T10 to 50 for all sections. While for beam design, from manual calculation, we provide reinforcement with size HC100 to HC300, and based on STEAM software, provided reinforcement is T10 to 50 for all sections. Okay, proceed with column design. The reinforcement provided based on manual calculation is between HC160 to H10300, while software provided 8T12 for all sections. Next is pad footing. So for pad footing, reinforcement provided based on manual calculation is ranging between H10 to H1816 for transverse and H85 to H1216 for longitudinal, while software provided between T1116 to T3112 for transverse and T1712 to 30T12 for longitudinal. Okay, by comparing both calculation, it can be concluded that our design is fast and there is no failure occur during the design. During the design phase. I think that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Natira binti Muhammad Rusli, number matric CF 2095. So today I am going to present on earthwork for our project. So the total area of our project is equal to 50 acre with total cut area equal to 8,707 meter cube, and total field area is 10,780 meter cube. The figure shows the shaded area for cut and fill. The blue one is for cut area and red is for fill area. I think that's all from me. Thank you.
Hi, my name is Nurul Izzah binti Emanja. I present about the road and drainage. So, drainage function is to remove the water from the road and surrounding area, and to ensure that the open space provided in the overall layout plan is adequate. The objective of drainage is to purpose a stormwater management option for the layout plan, approval of a purpose 4-story office building or commercial building in Kuantan, Pahang. Importance of road and drainage cannot be overstated because it removes all excess surface and subsurface water from the right of way. Next is the design stage. First, Urban Stormwater Management Manual. Stormwater flow rate after development should be roughly equal to pre-development condition. Second, aspect of stormwater management. Controlling flooding and reducing erosion and improving water quality. Third is best management practice, BMP. Practice that are structural, vegetative, or managerial in nature and are used to treat, prevent, or reduce water pollution. Result, purpose that any additional runoff generated by development be directed to a suitable detention facility. Calculation of drainage design. So the calculation for design flow for the drain are 10 years. So the location is at Pahang, Kuantan. So the coefficient of IDF polynomial equation, we choose design ARI for 10 years, and we can get the rainfall intensity for 30 minutes is 96.95 mm per hour, and rainfall intensity for 60 minutes is 66.39 mm per hour. For the rational method, we insert the overland distance is 145 meter, drain distance is 519.3 meters, and the slope percentage 2%, assumed velocity is 1 meter per second, and roughness coefficient N is 0.011 for concrete asphalt drain, and the overland sheet flow travel times is 5.37 minutes, and time of flow in storm water conveyance system is 8.66 minutes. Thus, the time of concentration TC is 14.03 minutes. Storm duration adjustment factor FD is 0.11. This only apply if the TC is below 30 minutes. And the design rainfall depth is 56.38 millimeters, and the rainfall intensity is 241.1 millimeters per hour, and the runoff coefficient is 0.9. The soil condition is urban category 1, and the catchment area for our project is 22.42 hectares, and we can get the peak discharge is 13.5 meter cube per second. So from the calculation, we can state this is okay. So this is the drainage design. So the drain section we has stated, and we propose the drain design is 300 times 600, which is all the calculation is passed for this size. So this is our flow for the purpose drain design and the road design, and this is the typical type of the drain design that we propose for our project.
Okay, next, I will continue to explain about the road network project. Okay, design briefing. There are 4 types of roads, which are main road, collector road, residential road, and Belen road. They are in our site plan. Main road is a continuous road which partial access control for through traffic in urban areas, and it basically converts traffic from residential areas to vicinity of the central business district, or from one part of a city to another which does not intend to penetrate the city center. Collector roads is the major road which penetrate and serve identifiable neighborhoods, commercial areas, and industrial areas. Residential road is the basic road network within the neighborhoods and serve primarily to offer direct access to a building land, while backlink road is the road at the back of shop lots that connect to the arterial road for the heavy vehicle to transfer their goods. Hence, for this project, we focus on more for collector road, which is the road that are in our construction buildings, which is commercial building. Traffic design and traffic flow report for 4 levels of hierarchy. For collector road, the design properties of road, which is group area is urban area, road category is arterial, traffic volume for 2022 is 5,304 vehicles per day, annual growth rate is 4% per annum, design period 20 years, project annual daily traffic, which is ADT, is equal to ADT not 1 plus R power of n, which is if we calculate the traffic volume of road completion to 2038, which is ADT, we get the answer is 1198.88, which is approximately to 1199 vehicles per day. We assume that it has a two-way, two-lane arterial with HDT is to 28,000 vehicles per day in 2022. Urban K is equal to 12%, V15 equal to 850 vehicles per hour. First of all, we determine the V, which is in unit vehicle per hour. The V we get is 3,360 vehicles per hour. Second, we determine the road capacity, which is RC, which is also in same unit, which is vehicle per hour. The pressure we get is 0.99, the FHP we get is 0.79, the RC we get the 2091 vehicle per hour. The V over C we get in 1.61, which is greater than 1.0. Since VC is greater than 1, increase the value of n and recalculate the RC. The new RC we get is 5,772 vehicles per hour, which is V over C new is 0.58, which is smaller than 1.0. Therefore, n equal to 4 and design for dual two-lane carriageway. Loss equal to C, which is in low to moderate density. Okay, next part is road pavement thickness design for 4 levels of hierarchy. For the collector road, the design properties is which is first initially the traffic volume ADT 5,304 vehicles per hour, percentage commercial vehicle which VC is equal to 4%, annual growth rate which is R is same which is equal to 4%, equivalent factor which is E equal to 2.0, separate CBR which is 5%. So first of all, we calculate the initial annual commercial vehicle traffic which is V0. We get the answer is 38,719 vehicles per hour. Second, we calculate the total number of commercial traffic one way for the design period of 20 years, which is the VC we get is equal to 1.153 times 10 power of 6 vehicles per year, which is approximately to 1.1 times 10 power of 6 vehicles per year. Next part is we continue the calculation, which is total equivalent standard as the law, which is ESAL estimation. The ESAL estimation we get the answer is 2.2 times 10 power of 6. Next, we continue with the maximum hourly one-way traffic flow, which is C. the C is equal to I times R times T, which is I is the ideal Hawley capacity, R is the Rodaway factor, and T the traffic reduction factor. Assume that rod 2 length and carriageway width is 7 meter with 1.00 meter shoulder width. The T we get is 0.96. The C small letter is we get 758 vehicle power. The C capital letter, which is 10 times C small letter, we get 7,580 vehicles per day per lane. Next, we calculate the Vx, which is ADT times 1 plus R power of n divided by 2. The answer we get is 5,811 vehicles per day per lane. Okay. Next, this is the table of the layer thickness, which is layer for wearing cost, binder cost, base cost, and sub-base cost. For the graph, the corrected equivalent thickness, which is TA equal to 22.5. For the first trial and error, and we get the TA 23.25, which is smaller than TA. We move to second trial and error, we get the TA equal to 22.9, which is greater than TA. As the wearing is 5 cm, the binder is 8 cm, the base is 18 cm, and the sub-base is 18 cm. This figure from 3.3 shows the pavement thickness of the collector. Okay, next I will explain briefly about the sewerage design. So first of all, for the introduction of the sewerage design. Wastewater refers to all effluent from household, commercial establishments and institutions, hospitals, industries, and so on. It also includes stormwater and urban runoff, agricultural, horticultural, and aquacultural effluent. Effluent refers to sewage or liquid waste that is discharged into water bodies either from direct source or from treatment plants. Sewage is also wastewater. It is wastewater originating from toilets and bathroom fixtures, bathing, laundry, kitchen sinks, cleaner, and similar dirty water that is produced in household and public places. Water used to irrigate turf and gardens, swimming pools, roof drainage, surface runoff, and stormwater are all wastewater but not classified as sewage. Sewerage is the system of the pipes, pump, and other physical infrastructure that conveys wastewater or sewage from the point at which it is treated to the point where it is treated or disposed. Type of sewerage system. It is the system and infrastructures of collecting, treating, and disposal of sewage. There are three sewerage system types, which is first of all separate system, second partially separate system, and third combined system. In this project, separate system is used. In this system, the sanitary sewage and stormwater are carried separately into sets of sewer. The sewage is conveyed to wastewater treatment plant, which is WWTP, and the stormwater is discharged into river without treatment. The separated system is suitable when separate outlet for stormwater is available and the topography is such that stormwater can be disposed of in natural drains. So for the standard reference, we use MS 12228 1991 Code of Practice for Design and Installation of Sewerage System. It is used to design the discharge of wastewater flow as required. Second, we use environment quality, which is wastewater and industrial effluent 1974, as the effluent discharge must meet the standard A and B, which is A for the pipe and B for the manhole. So, design criteria for the pipes and manhole. First of all, for the pipe, depth of sewers is equal to first 1.2 meter below the ground surface, and invert depth which is minimum of 1.2 meter. So basically, this is a depth of sewers so from MS1 to 281991. So second, for the velocities of the flow, minimum of 0.8 meter per second to prevent the sludge to settle in the pipelines. So the maximum is at 4 meter per second to prevent scoring of sewer by erosive action or suspended matter. So basically, this is a figure velocities of flow which is sourced from MS1 to 281991. So for the slope of the pipe gradient, which is 1:2200 to 1:35 to maintain the velocity. So the size of the sewer, first, sufficient to handle the total discharge Q, which is EQ is greater than peak flow total. Second, minimum size is 200 mm, and reinforced concrete pipe available size range is about 150 mm to 3000 mm. So basically, the size of sewer which is sourced from MS1 to 281991, and the size of sewer also for the same source. So second, for the manholes, locations are situated at the end of line, intersection of sewer, change in direction, slope or size of sewer, and at least at 100 meters apart of each other for ease of maintenance. So basically, this for the design procedure. There is 6 steps for the design procedures, which is first for the network sewer planning, second step is sewerage layout plan, third step is determination of operation equivalent, fourth step is determination of peak flow, discharge, type and size of the pipe, fifth step is determination of velocities and invert level, and last but not least for the sixth step is summary of sewerage design. So first of all for the step 1 is network sewer planning. The sewerage pipe must be located in the surrounding area of the road. The pipe to be located in private property due to certain topographies must apply for the permission to certain individual before the construction can begin. Before any construction work can begin, the layout and the overall existing building, pipe and electrical must first to be determined. During the construction work, the separation of sewer and the main water should be required of minimum horizontal separation of 3 meter and a minimum vertical separation of 46 cm from water mains. So for the second step is sewerage layout plan. So basically this is our sewerage layout plan for the proposed sites. For the third step is determination of population equivalent and type of sewerage system. So basically we calculate the population equivalent, which is PE. So we total population equivalent PE from the proposed site. Type of sewerage system. The sewerage system that is greater than 150 PE, which is commonly for complete system, sewer network, MPS, and STP. Second is sewerage system is below the 150 PE, commonly for septic tank and connection. The PE may be converted to a flow rate using a simple formula such as set-out measure standard, which is 1228 MS1228. So for the first step is determination of peak flow, discharge, type and size of the pipe. And for the next step is determination of velocities and invert level. And last but not least, for the sixth step, the summary of the sewerage plan. Basically, depth of sewers more than 1.2 meter is passed, velocities of flow in the range of 0.8 meter per second to 4.0 meter per second is also passed, slope of pipe gradient between 1:200 to 1:25 is also passed, total discharge, which is Q, is greater than peak flow total is also passed, minimum pipe size is 200 mm is passed, and for the design criteria for the manhole, the locate manhole is suitable location is also passed. So that's all from me. Thank you.
My name is Nurlit Diana binti Khalid and I'll be presenting the water reticulation. The water reticulation system. Point A says there are numerous sources of water including rivers, lakes, and streams. The water distribution network is a component of every mature social structure. It is an infrastructure layer consisting of pipes and fittings. The purpose of the regional water supply system is to provide all of the water required for human consumption. Phasing and demand. The daily demand is estimated using the following water consumption rates extracted from the Malaysia Water Association. Computation of demand. For a 4-story office building, it is 1,800 demand GPD per room. Source of water. The water source and tapping point shall be derived from the existing SEDA main designed by engineer consultants chosen by the developer. Distribution of pipe network. The distribution system shall be comprised of mild steel pipes, valves, and upper tendencies, all in accordance with SEDA specifications. At the road crossing, mild steel will be piped inside with cement mortar and bituminous felt will be given externally. Hydrant flow. Based on Malaysia Water Association requirements, our proposed construction falls under Class B, so only one hydrant flow of 2,700 liters per minute is used simultaneously for the entire region. Our daily water demands is 0.02803 liter per second. Our hydrant flow is 45 liter per second. Our total water demand is 45.03 liter per second, and our peak flow at node 2 and peak flow normally is 0.07 liter per second. Here shows the EPANET layout of water reticulation using the EPANET software.